Hello everyone and welcome back to another video. In this project I'm going to describe the RFID based smart and secure door lock system. So it is an extension of the previous one as usual. The previous two projects were based on password protected door lock system, and the later one was the OTP based smart and secure door lock system, and this one is the extension of the previous one. In this case the door lock will be opened on basis of the identification of RFIDs. So first of all, as usual, I will be describing the components that I've used here, and then I will describe the features of my project, and finally I will directly dive into the demonstration of my project on how it works. So I have described most of these components before, but except this RFID reader. So I will describe in details about this RFID module, and the other components. In case of the other components, I will only mention their name, but if you want to check out the details about these components, then I suggest you to check the first video on the door lock system, which was the password protected smart and secure door lock system. So if you want to know about the details of each of these components, then please go and get a view over that video. So let me start mentioning all of the components that I've used here. First of all, as the microcontroller, as usual, I have used the ESP32 board. It has the built-in Wi-Fi that will allow me to connect with the internet and therefore send the notifications, the alerts by email. And then as the door lock, I have used the 12 volt solenoid electric lock, which is powered by these three cells. Each of these cells are of 3.7 volts. And in order to drive this solenoid electric lock, I had to design a driver circuit using the NPN bipolar junction transistor BC547. And once the bipolar junction transistor receives control signal generated by this ESP32 microcontroller, it supplies the electric door lock with this 12 volt, and the coils inside this electric door lock in that case get energized. However, as the coils are inductive, once they discharge, they may allow to flow reverse current, current in the reverse direction. That may eventually interrupt the operation of the other modules connected in the entire system. Like it may interrupt the operation of the microcontroller, it may interrupt the operation of the LCD display. So in that case, in order to prevent any reverse current to flow through the load or through the entire system, I had to connect a PN junction diode. As you can see, it's very popular. I think the model is 4007. So I connected this PN junction diode across the load, across these two wires, more specifically I should say. Eventually, this prevents any reverse current to flow through the load eventually to the entire system. So that it may not interrupt the operation of other modules connected in the entire system. It happens because the electric door lock inside it has the inductive coils, and once they get discharged, they may flow reverse current through the load or through the entire system. So in order to ensure smooth operation of each and every module connected to the system, it's very important that you're connecting a diode in the reverse direction with the electric door lock, with the two wires of the electric door lock. I believe that you can see the PN junction diode. Next, I have used the 20x4 I2C liquid crystal LCD display in order to design the user interface. Below this, there is the I2C driver. The I2C driver allows me to work with the LCD display with the least possible number of wires, which is 4 in this case. And then, as you can see, there is a buzzer and a red LED that will be notifying me about any unauthorized attempt to enter the door, and the green LED will notify me if the door has been opened or not. And then, as you can see, there is a IC7805 that eventually will step down the voltage supplied by this pair of batteries to 5 volts and then power the LCD display. And then as you can see that there is another pair of battery that will be supplying power to my GSM module, which is a SIM900A GSM module. So as you can see that it's already been powered, and the LED on the SIM900A GSM module is blinking once in every 3 seconds. So it's a clear indication that the same 900A GSM module has been established on network. If it blinks faster, then it means that it's not been established on network. And it's been powered by this pair of batteries, which is stepped down to 5 volt using this another 7805 voltage regulator. And then this is the RFID reader. RFID stands for radio frequency identification. It scans the tags. I have here 3 kind of tags. 2 of the tags were given with the module and 1 I had before. So this is the card type tag, and this one is the ring type tag. And I have another tag which was given with one of my cell phones, one of my smartphones I should say, which I purchased in back in 2013. So once I was using this module right now, I thought of checking if the NFC tag that I was given while purchasing this cell phone works. And yes, apparently it's working right now. The RFID reader is able to scan the unique ID inside this NFC tag. So right now, let me tell you how the RFID works. So the RFID stands for radio frequency identification. It checks for the unique IDs inside each of these tags. As you can see, each of these tags, inside them they have a chip, and the RFID reader scans for the chip and it extracts the unique ID which is contained in each of these chips. So each of these tags have different IDs. I mean, they have their own UID, also known as the unique ID. So first of all, using a dump code, I have to extract the unique IDs of all these 3 tags. And then I had to authorize only one of the tags with my system. If you want, you can authorize more tags with your system. But for the time being, for the sake of demonstration, I have authorized only this tag. So if I scan my NFC tag or my ring tag, then it's not going to be authorized. So only the card tag will be authorized by the system and the door lock will get unlocked. So that's all about the NFC tag, and you can purchase these cards as a spare, but I didn't purchase any spare cards. I only have one of the card type tags, another ring type tag, and the other is the NFC tag. As I've already told you, I've got this with my smartphone back in 2013, around 10 years back. I haven't unpacked it from the pack. It works like this, so it's not a big deal. And then in order to unlock the door from inside, I have used the 4-channel touch capacitive sensor. Using only one of these channels, I can unlock the door from inside. So I believe that I have been able to describe all these components. I have already described these components in my first video of the door lock system, which was the password protected, smart and secure door lock system. But in this case, the new component was the RFID reader, and I have already told you about the RFID reader. Another fact that I would like to mention here, that it's very important to check the pinout, once you're connecting this with your microcontroller. So there are SDA and SCL port in the RFID card reader, and you have to connect it with the ESP32 board. So the RFID uses 2 of the I2C ports, the SDA and SCL ports, as well. This LCD display also uses 2 I2C ports. So the default I2C port on the ESP32 board is GPIO 21 and GPIO 22. But right now you have 2 I2C devices. One is the RFID and the other is the I2C LCD display. So in order to use both of these I2C devices with your microcontroller, you have to declare another pair of ports as SDA and SCL ports. And I've done so by calling the wire function. Initially I called the wire.h library function, and then I created an object under the wire library, and then I called the wire library function, giving the arguments of the SDA and SCL ports. I don't exactly remember the updated SDA and SCL ports. But if you wanna see the SDA and SCL ports, then I can show you. Let me check out the code. Most probably I set it up in the void setup portion. Just give me a while. I'll be showing you the SDA and SCA ports. So you see wire.begin 27, 26, and maybe the value is 100,000. Yes, 100,000. So wire.begin 27, 26, 100,000. 27 and 26 stands for the customized SD and SCL ports, and 10,000 is the frequency or the speed at which it will be communicating, or the rate at which the device and the module will be communicating with each other. So 27 is the customized SDA port and 26 is the customized SCL port. And I have connected my I2C LCD display with these customized SD and SCL ports, and with the default ports I connected my RFID card reader module. So it's it's one of the methods that you can follow. Even by multiplexing, you can use the same pair of SD and SCL ports with different modules. That's another approach. But in my case, I have declared a customized SD and SCL ports, and then I connected two of my I2C devices with those two pairs of ports. So I believe that I have been able to describe all of these components. I believe that it's quite clear to you right now. So this was one of the important factors, to use two different I2C ports with two devices. And the other factor was here to use the PN junction diode that I skipped in the previous two videos. But it's very important to ensure that you are connecting this PN junction diode at reverse polarity with the electric door lock in order to prevent any backflow or reverse flow of current through any component in the entire system. Now I would like to describe the features of my project, what it will be doing. So first of all, as an authorized tag is brought close to the RFID scanner, the door lock will get unlocked, and a notification will be sent to you by an email as well by an SMS to your cell phone. Secondly, if an unauthorized card is brought to the RFID, in that case, the door will not get unlocked. Rather, the green LED and the buzzer will go up, alarming you that suspicious attempts have been made, and an SMS and an email will be sent to your device about the suspicious attempt to unlock the door. The third feature is, if someone is inside the door, then it's not important for him to unlock the door using the NFC tag or the RFID tags. So in that case, he can easily unlock the door by pressing on one of the channels of this 4-channel touch capacitive sensor. And the fourth feature is, if you are far away from your residence and if someone is trying to enter, someone that you know is trying to enter your room and you want him to enter your room, in that case, you can unlock the door remotely from any corner of the world simply by sending an SMS. So these are the features of my project. I believe that I have been able to clarify all of the features. So right now, I would directly like to dive into the demonstration. So before starting the demonstration, I would like to reset the ESP32 board. Let me open the serial monitor to observe the progress of everything. As I have a very weak broadband network right now, due to adverse weather conditions, it will be a bit difficult for me to connect with internet, as the ESP32 board will connect to my existing broadband network. So let me reset the ESP32 board and start from the very beginning and show you what happens. So welcome to Rafi Smart Door Lock undergrad student development of EEE BUET. And then I can see on the serial monitor about the progress. Yes, my ESP32 board has connected with the Wi-Fi. I don't know about the strength of the network. As well, the GSM GSM module is also established on the network. So it's working fine. So right now, I will be scanning the authorized ID, which is my which is the card in this case. So I'll be scanning the card right now. I believe that you can see, and you will see that the door will get unlocked. So I believe you can see. You see, the door got unlocked, ID verified, door unlocked, sending first alert, which is an SMS. And if you want, you can see the progress, whether the mail is being sent. It's connecting with the server. As I've already told you, it takes around 20 to 30 seconds. And as you can see that it's been able to send the alert. The second alert will be an SMS. Both of the alerts have been sent. And right now I'm going to show you whether the alerts have been sent. So first of all, let me show you my mailbox. So I'm going to refresh this page and show you the mailbox. Alert from Rafi's automation, door alert, I believe you can see the very last alert, which is a door alert, identification verified, door unlocked at 12:04, 0 minutes back, and the time is 12:04 right now. And right now I will be showing you my inbox, SMS inbox on my cell phone. As you can see that there is an SMS over here, identification verified, door unlocked at 12:04. And as you can see that the time is 12:05 right now. That means the SMS has been sent right now. Right now, I'm going to show you some unauthorized attempts in order to enter the door. For example, if I scan this NFC tag, let me show you what happens. It's not authorized. So let me show you what happens in that case. Okay, it's not being scanned. Okay, I don't know why it's not getting. Okay, it's quite clear to me. My code got stuck. So I have to reset the ESP32 board. I'm so sorry for the inconvenience. It will take only a few seconds to reset the ESP32 board. I believe it will be reset. Yes, it's been reset, but it's not been able to connect with the Wi-Fi. As I've already told you that I have a very weak internet connection right now, as a result of which the ESP32 board fails to connect with the internet. So I've reset it for one more time and checking if it's able to connect with the internet. No, unfortunately the ESP32 board hasn't been able to connect with the Wi-Fi, so I can't show you the email alerts right now, but I will show you the SMS alerts. So if you attempt to enter the door lock with unauthorized IDs, for example with this NFC tag, let me show you what happens. You see unauthorized ID, please try again. So the first alert hasn't been sent because there is no internet, and the second alert was an SMS, which will be sent to my cell phone and which has already arrived to my cell phone. And if you want, I can show you. Give me a second. Perhaps the video is being a bit lengthy. I'm so sorry about that. Suspicious unlocking attempt detected. Now if I scan this ring, which is also unauthorized, let me show you what happens. You see unauthorized ID, please try again. And it's sending me the second alert, which will be an SMS. The SMS should be coming very shortly. And as you can see, the last message I should say, that's telling me suspicious unlocking attempt detected at 12:07. So it's working fine. Now the third feature, if someone attempts to unlock the door from inside, then let me show you if he can do so. So in that case, only what you have to do is press on the first channel. You see, button pressed, door unlocked. So it's working fine. You just have to touch on one of the channels and it will unlock. Button pressed, door unlocked. I believe that it's quite clear. And the fourth feature is you can remotely unlock the door from any corner of the world simply by sending an SMS. I've reset it for one more time just to check if the Wi-Fi gets connected. Yes, fortunately my internet is back, connected to Wi-Fi IP address, you can see. So I can show you the last demonstration with the mail alert as well. So now you can simply unlock the door by sending an SMS, and no matter what you write in your SMS, it's very important that you're including the substring unlock with the uppercase U, as I've already told you in the previous video, because the program will look for the availability of the substring unlock with uppercase U in your sent message. So I'm trying to write something like unlock the door please. So I'm sending it and show you what happens. Yes, unlock the door please. And let me see if the message gets delivered. It hasn't been delivered. I believe it will be delivered shortly. There is network issue as well. You know, the weather is not good at all. It's raining outside, cats and dogs. So sometimes it takes a while to send the SMS. The SMS hasn't been delivered. Maybe it's due to the network issue. Yes, it's been delivered. I don't know if it's been delivered to my GSM module. Okay, the GSM hasn't been able to catch the SMS, so maybe I'm going to reset the GSM module and check if it works. So I'll be waiting I want you to wait for a while. Let me see if the GSM module gets established on the network. It's blinking once in every 3 seconds. Yes, it's established. The door lock is also working fine. So let me send the SMS for one more time and check if it works. So I've sent another SMS. It should be delivered. It's been delivered, but my code hasn't been able to catch it. So I'm going to reset the board for one more time. I believe that the GSM got stuck. Yes, I can see it in my serial monitor that the GSM got stuck. So what I'm going to do is I'm going to reset it for one more time. The reason that the GSM got stuck is the most probably the power supply issue. You know, my batteries are of very bad quality, and okay, that's why they run out of power, you know. So this time let me show you if it works properly. Reset the board, and yes, it's been established on a network. So right now, if I want to, then I can remotely unlock the door lock, and it's also connected with internet. As you can see, it's established on GSM as well on Wi-Fi. So I'm going to send the string, unlock the door please. I have sent it just now. Let me see. Yes, it's been delivered, and as you can see, request verified, door unlocked, sending first alert, which will be an email, and you can see the progress whether the mail is being sent on the serial monitor. Yes, the progress is positive, and yes, the mail has been sent. So I'm waiting for the second alert, which will be an SMS, and it's also been sent. So let me check my inbox if the messages got arrived accordingly. And as I've told you, due to network issue, it sometimes takes a bit of time. Even in case of GSM, it happens that the SMS doesn't arrive right now, but after a while. It's all about network issues. So as you can see, door unlocked remotely using SMS. Thank you. Message sent 0 minutes back at 12:12. I believe that I have been able to verify the operation. I'm doing the same thing for one more time. Unlock the door please. Okay, I'm running out of SMS bundles. I only have maybe 3 messages left. Well, the message hasn't been sent. I'm trying to send another. Okay, the message should be sent. Let me see what happens. Resetting the board. I've run out of SMSs from my inbox. I'm so sorry for delaying the code. I mean delaying the demonstration, not the code. I'm getting a bit messed. I'm so sorry about that. So here I have connected my GSM module. It will be established on network. It is established on network. No, it's not established on network. It's blinking faster. Maybe it's short of power. No, it's not short of power. It's established on network. So I'm trying to send the string. Unlock the door please. The message has been delivered. Well, I've run short of balance. That's why they are not being sent for the time being. That's not a big deal, but I've been able to show the fact for a single time, I guess. Again, the GSM module is also not established on network because it's blinking. It was blinking, you know, faster than once in every 3 seconds before. But right now, again, it's established. So due to network issues, you know, these ambiguous factors are being seen, and I do apologize for that. I believe I have been able to clarify. It was a bit messy. It was a bit, ambiguous due to network issues. I believe that you have been able to get the point very well. And sorry for this network issue. The weather is very bad outside. It's raining cats and dogs. So that's all for now. Thanks for watching. Stay tuned for the next one. Bye for now.